In part one, we looked at what happens when one of the players gets to move first, and that changed the game. In this case, in example 4, that won't be the case. Why? Well, we have dominated strategies. So if the players move simultaneously, they're both playing the dominating strategy. Rose plays A, and Colin plays B. And what does Rose do if she goes first? She plays A. What does Colin do if he goes first? He plays B. And so that doesn't change whether they go first or second. You can see the game geometry here. So where this game is solvable in the strict sense, the saddle point is AB, Rose A, Colin B, which slightly favors Colin. Remember, Colin is trying to go as far north as he can along the Pareto optimal boundary. Rose would like to see if a threat or promise could move the game to this point instead. So let's take a look at this. The problem is that Colin sees this 4 and Rose is also doing better by 3/1, so Rose has to threaten. She's going to threaten if Colin, if you play B, then I'm also going to play B. Now I'm taking a hit. Rose B lowers her payoff by 2, but it also lowers Colin's payoff by 2. And so now his choice is between picking B and getting only 2, or if he were to pick A, he'd get 3. Well, now that threat's going to move him from playing B to playing A if it's credible. We talked about the credibility of commitments in part 1, and that's also important. This only works if Colin believes Rose. So let's look at the definition of a threat. So the key is that we agree to reduce our own payoff, but the threat is that it will also reduce our opponent's payoff. So Rose commits to a specific action based on something that Colin has done already, and Rose's action will be harmful to Colin and also harmful to Rose. Promises are the same. Rose commits to an action that's harmful to her. She decreases her own payoffs, but the promise improves Colin's outcome. So the threat hurts Colin, but the promise helps him. Notice that it's based on a prior action, so the threatener or the promiser has to be playing second. So what about the prisoner's dilemma? By the way, there's no threat that works in the prisoner's dilemma because the dynamics push us to this ugly point, and we can check out the geometry to see that the prisoner's dilemma has 3 Pareto optimal points, one that's really, really good for Colin, one that's really, really good for Rose, one that an objective observer would say is best, but the Nash equilibrium is the 0, 0. And the only point that's not Pareto optimal. That's why it's called the prisoner's dilemma. And nothing changes. If Rose goes first, she defects, then Colin defects. If Colin goes first, he defects, then she does. And the game isn't threat vulnerable. I mean, what could Rose do? Threaten if you play B, I'll play B? That's what she'd do anyway. That's not harmful to Rose. So Rose doesn't have a threat. Maybe you should pause the video here and see if you could find the promise that works. You should do the reading, and when you do, Strafen makes the point that raising the value, a promise raises Colin's value essentially, and a threat decreases it. So that's what we need to do. We need to give Colin a reason to choose A over B. Well, here's what Rose can do. She can say, look, I'll make sure you get 3 instead of -1. So she's increased Colin's payoff by 1. So here's the promise. Rose says, Colin, if you'll play A, then I'll play A. Now it's a strategic move. It's a commitment because she is reducing her own payoff by 2. But now she's having Colin choose between getting a 0 if he plays B and getting a 3 if he plays A. So this promise is going to work. By the way, we should think about this when we're writing this out in words. You need to specify the players. So in words, you'd write on a quiz or test, if Colin A, then Rose A. The threatener or the promiser is always the second player, so if you write it in that form, then it's clear which player is moving first and being threatened and which player is moving second and doing the threatening or the promising. Now 14.6 is interesting. We again have a game that's solvable in the strict sense. 1,5 is the solution. You can see that Colin has dominance here, so nothing changes as we make Rose go first or Colin goes first, because Colin B dominates A, so he's always playing B when he goes first. Then Rose plays A to get the 1. If Rose goes first, she's choosing. If Rose goes first, she knows that Colin's going to play B because it's dominated no matter what. So if and we get back here. So the same outcome of the game happens no matter who moves first. But let's look at this game geometry, because you'll see that the equilibrium, the solvable in the strict sense solution point, is here. That's the Nash equilibrium. But Rose has this Pareto optimal point, which would be, an objective observer would say, better for both players, or this one that's strongly favorable to her. What she'd like to do is see if she could make some threat, say, hey, I'll play this ugly game outcome if you will help me out by playing a more favorable one for me. So let's see what we can do. Now, a threat doesn't work by itself, right? She can't say if B, then B, because then Colin would simply be choosing between a 2 here and a 3 here. Wait, I'm sorry, and a 0 here, right? Because Rose would play the 4. And 2 is better than 0, so he'd still choose B. So a threat by itself doesn't work, and you can check that a promise doesn't work. You should pause the video here and see if you can find the threat-promise combination that works. So now that you're back and you know we have to threaten if B, then B. So if Colin plays B, then Rose threatens that she will also play B, but yet she also has to make a promise that if Colin will be nice and play A, Rose promises to also be nice and play A. So what does this do? Well, if Colin plays B, it reduces his outcome from 5 to 2. Ooh, that was ugly. So it reduces Colin's value from 5 to 2, but here she's saying, hey, I will improve your outcome from 0 to 3. Now his choice is clear. If he plays B and believes the threats and promises are credible, he only gets 2, whereas if he plays A, he can get 3. So this is a situation where you need a threat-promise combo to make this work. You definitely should read the rest of this chapter. Strafan makes some excellent points, and there's good homework problems that will help you understand strategic moves.